we have seen something about constructors. Okay, constructors are also executable blocks in a class. Okay, like methods, even constructors are also executable blocks in a class, and the constructor name should be the class name, and the constructors can have zero arguments or any number of arguments, and we can have multiple constructors in the class. Okay, and the constructor can be overloaded. Okay, constructor can be overloaded, and a constructor cannot be static. Not even static, any other access modifiers are not allowed for constructors. Even abstract or final or transient or any other access modifiers are not allowed for constructors. Okay, so when you create a object, okay, how we can create a object means new followed by a constructor. When we create a object using new followed by a constructor, when we create a object using new followed by a constructor, okay, then first the object will be created in a heap. As a second step, okay, the attributes will be loaded into the object. As a third step, default values will be assigned to the object. As a fourth step, okay, the references to methods will be created, and as a fifth step, okay, a temporary reference will be created to that object in the stack. And then after, the execution part will be done. Then after, the constructor will be executed, and after executing the constructor, the next step will be done. Okay, like that the process of execution was, that was the thing that we have discussed yesterday. And the temporary reference created for an object will be available only to that statement. Will be available only to that statement. And if you come to the next statement, the temporary reference will be expired. So, if you want to reuse the object, okay, we need to create a permanent reference. And how we can create a permanent reference means new construction will have a temporary reference which will be available to that statement. So we will assign the temporary reference to a permanent reference, so that this permanent reference will be available throughout the main method. This permanent reference will be available throughout the main method. Okay. See, the scope of this permanent reference will be throughout the main method. Okay. Now, can I call P as a local variable to main? Can I call P is a local variable to main? Yes or no? Yes. Okay. P is a local variable to main. If P is a local variable to main, then what is the scope of P? It can be used only within the main method. It cannot be used outside the main method. Okay. So until the end of the main method, till the end of the main method, P exists. Till the end of the main method, P exists. Okay, so we can reuse the permanent reference P, okay, until the end of the main method. But we cannot use this P inside this. Okay, or we cannot use this P outside the main method. It's not possible, just because P is a local variable and can be used at maximum, can be used only in the main method. Okay, now. How many objects that we have created here? How many objects we have created here? 3 objects, right? And if we come to the ninth statement, okay, how many objects have references? 1 or 2 or none? If we come to the ninth statement, in the ninth statement what I am assigning P dot id equal to 10. In that statement, how many objects have references? Only 1. Okay. And what about the remaining objects? The objects that are created in 6th statement and 7th statement, Do they have references when I come to the ninth line? No. Okay. The objects that doesn't have any references from the stack are called as detached objects. Okay. The objects that doesn't have that doesn't have any reference from the stack are called as detached objects. The objects that doesn't have any references from the stack are called as detached objects. And the detached objects will be automatically removed. The detached objects will be automatically removed from the heap by the garbage collector. Okay, there is a thing named garbage collector. There is a thing named garbage collector. What the garbage collector will do means, the garbage collector will remove all the detached objects from the heap. Okay. The garbage collector will remove all the detached objects from the heap. And let's consider the garbage collection of this heap to the garbage collection of our hostel. Let's consider I am staying in the hostel. Okay, and the hostel whose fees. Let's consider here he is the garbage collector. Okay, now will he come whenever you want, or will he come only at a specific point of time at the day? Only at a specific point of time he will come, and if you have some garbage, then he will remove the garbage. Okay? It doesn't mean that whenever you have garbage, he will not come. Okay? He will come at a specific point of time. At that time, if you have some garbage, then he will remove them. Okay? In the same way, okay? Our garbage collector also, what it will do? It will not be invoked. It will not be invoked whenever there is a detached object. Okay? Whenever there is a detached object, most of the people will think that whenever there is a detached object, garbage collector will remove. It's not like that. Whenever there is a detached object, the detached object will be there in the heap. Until the garbage collector is invoked. The garbage collector will be invoked by the JVM at a very regular intervals of time. Like the speaker comes every day morning. Okay? The garbage collector will be invoked by the JVM at a very regular intervals of time. At that particular time when the garbage collector is invoked, if there are detached objects, then those detached objects will be removed from the heap. Okay? Just the process will be like that. When the garbage collector is invoked by the JVM, if there are detached objects, then automatically the detached objects will be removed from the heap by the garbage collector. Okay? So this is how the Java maintains the memory, maintains the balance of the memory. When there is a detached object, and those detached objects will be there until the garbage collector is invoked. Once the garbage collector is invoked by the garbage collector will remove all the detached objects. So the memory will be balanced. Now, can we tell that the memory management will be automatic in Java? The memory management is automatic in Java. Okay? Automatically the garbage collector will be invoked. We need not to write any code to invoke the garbage collector. Automatically the garbage collector will be invoked, and automatically the cleanup process will be done. The cleanup means removing all the detached objects from the heap. If we are removing all the detached objects from the heap or all the unused objects from the heap means we are cleaning the heap. Okay, we are cleaning the heap. So this cleanup process will be done automatically. We need not to write any code to perform this cleanup process. This will be done automatically. That's why we say that Java has automatic memory management. Okay? Java has automatic memory management. But if you go for C++, the objects will not be automatically removed. The objects will not be automatically removed. For each and every object creation, we should invoke a constructor. In the same way, for each and every object destruction, we should call a destructor. There is a concept of destructor in C++. That means, if you want to clean an object, if you want to remove an object from the heap, we should call it destructor in C++. But a concept of destructor is not there in C++. Whatever the action that is done by the destructor in C++, it is automatically done in Java by garbage collector. And the garbage collector will be invoked by the JVM at a very regular intervals of time. So, it will be automatically cleaning the memory. We need not to trigger that. Understood how the objects are created and how the objects are removed? Okay? When the object is removed means the object, it doesn't have any reference, then it is eligible to be removed. It doesn't mean that it will be removed at that point of time. When the object doesn't have any reference, then it is eligible to be removed. Okay? And that object is called as detached object. Okay? Once the garbage collector is invoked, then it will remove all the detached objects from the heap. Okay? That's the process of memory cleanup. And now, how many detached objects are there at the 8th statement? There are 2 detached objects at the 8th statement. Now, let's consider that I'm making p equal to none. Now, at the 13th statement, at the 30th statement, how many detached objects are there? See now, P is referring to this object whose ID value is 10, sorry, ID value is 200 and name value is none. Okay, now at some 11th statement, what we are doing is we are changing the value to 200. And at the 12th statement, what we are doing? We are assigning P to none. And up to 11th statement, P will be referring to this object, to the object which is created. But in the 12th statement, what we are doing? We are assigning P with none. We are assigning P with null means P will be assigned with the null value. And this reference, the link between P and this object will be removed. Okay? Now, some people will think that P will be referring to null as well as P will be referring to this object. But a reference variable cannot refer to multiple objects. Okay? A reference variable maximum can refer only one object. A reference variable P cannot refer two values. Okay? P cannot refer null at the same time it cannot refer an object. It should refer either null or an object. Okay? So, a reference variable cannot refer multiple values at the same time, multiple objects at the same time. Okay? A reference variable cannot refer multiple objects at the same time. Now, can I have multiple references to the same object at the same time? Yes. Can we have multiple references to the same object at the same time? Yes. Let's consider P, X, is one reference, Y is another reference. We can have multiple references to the same object. This is possible, and this is possible. But this is not possible. Okay? The same reference variable cannot refer multiple objects at the same time. This is not possible. Okay? So, when I try to assign P to null, what happens is, okay, the existing link will be removed. The existing link will be removed, okay, and null value is assigned. The existing link will be removed and null value is assigned. Okay, so now we don't have x and y, we have only p. Now, can I call this object as a detached object? Can we call this object as a detached object? Yes or no? Definitely, it will be a detached object. Just because it doesn't have any references. The existing reference P is also now pointing to null, not detached object. So, this is called as a detached object. Okay? This is called as a detached object. And once the detached object is formed by the garbage collector, it will be automatically removed. Okay? How many of you are from bioinformatics? Please raise your hands. All of you. Now, all of you have the knowledge of C? Yes? Could you able to get what I am telling? Or could you able to not catch this much speed? Or how it is? See, it should be reached to all. Okay? So, if you feel that whenever I am going fast, whenever you could not able to catch, okay? So just tell me so that I can go in a little bit more explanative manner or a little bit slow. Could you able to get the things what I am telling you? Could you able to understand the things what I am telling you? Everybody? Yes? Okay. That's fine. But if you are not getting the things or if it becomes difficult for you to understand if I am telling this much fast, then tell me so that I can explain it once again or I can go a little bit slow. Okay? Not even for them. If any other feel that I am going a little bit fast, just tell me so that I can go a little bit slow. Okay? Now, the objects are called as detached objects if they don't have any references. Now, let me tell that just draw the object diagrams in your notes. Okay, how the object will be and how the references will be, and tell your answer. Just draw the diagrams and how the references are assigned and which reference is referring to which object, and like that analyze the example and tell the answer. One second, let me modify this example a little bit. Just now, see the example. Just try to create the objects, try to have reference variables from the start, and see how I am assigning the reference variables and which reference is referring to which object. First P1 value then sorry, just ID and name. Then the name. One second. See, I have created two objects. How come we have one object here? But after Now let's see how we are going to do this. Okay, first we have a reference, we have created object person. Okay, we have created a person object which has ID, age, name. Okay, default values are 0, 0, 1. Okay, now we have a reference from the main method of the stack. It is P1. Okay, and what I am doing is I am creating another reference P2 equal to P1. Now P2 equal to P1 means given the reference P2 also refers to the same object where P1 is referred. So P2 will refer to the same object where P1 is referred. Okay, and again what I am doing, person P equal to P2. P will refer to the same object where P2 is referred. Where P2 is referring to this object. So now at this point of time this object has 3 references. It's possible we have any number of references to the same object. Okay. Now what I am doing is p.id equal to 10. Now this object id will be changed from 0 to 10 and name will be changed now to 11. Okay. Now sorry, before doing that, sorry, 0, 0, null. Okay. At the first, at the 10th statement, what we are doing? We are assigning P2 equal to new person. Okay. Let me come once again. First, P1 is referring to the object, and we are referring in the 6th statement. We are assigning P1 to P2. So P2 will be referring to the same object. And in the 7th statement, we are assigning P2 equal to P. So even P will refer to the same object where P2 is referring. So at 7th statement, all these 3 objects will be all these 3 references are referring to the same object. Now in the 9th statement or 10th statement, what we are doing? We are assigning P2 equal to new person. So since the execution will be started from the right hand side, so first a new object will be created with id as 0, age as 0, name as null. Okay. Now what I am doing is on the left hand side I am assigning the object to P2. Now already we have a reference P2. Okay. So this link will be collapsed. Okay. This link will be collapsed and P2 will be referring to the new object. P2 will be referring to the new object. Now, how P is referring to this object? How P is referring to this object? Through P2 or something else? See, through P2 itself, P got a link to this object. It doesn't mean that when P2 goes to some other object, P also should go to that. It's not like that. If you are reassigning P2 with some other object, only P2 will be P2 link will be broken and P2 will establish a new bond. But P will be referring to this object only. Understood? See, however we got a reference to the object, if we reassign that object or if we reassign the reference, then only the reference will be broken. Otherwise, the reference will refer to the base object only. Okay, with the current object only. Let's consider like if I assign P equal to some new object, then only the link will be broken. Otherwise, see, even though the link of P to this object was established through P2, even though let's consider from the first what we have done. We have assigned P1 to this object at the very first statement. And the second statement, what we are doing? We are referring to this object. Okay, P2 equal to P1. Okay, and in the third statement, what we are doing? Person P equal to P2. So P is for the same object. Now, how P got the reference to this object means definitely through P2. It doesn't mean that when P2 has broken its link with this object. Okay, when P2 breaks the link with this object, okay, it doesn't mean that P also should break the link. It doesn't mean that. Okay, if P2 breaks the link with this object, only that particular link will be broken. Okay, it doesn't mean all the objects that got the reference through P2 will break the link. It's not like that. Some people do things like that. Okay, even P has got the link to this object through P2. When P2 breaks the link, okay, when P2 breaks this link and P2 refers another object, P will remain intact. P will remain as this, and P will be referring to the same object as previous. It will not break the link. Understood? So what's the output now? What's the output? For the first two statements, what is the ideal name? 10? Ravi. And for the second? 0 and none. Understood? Understood everybody? That's how it will be. So just see how the references are going. Okay? Which is referred and which is dereferred. Like that.
Sir, if we want to link of A to B both sides, we don't want to break the link. What should I write?
That's important. There's no. An object can have multiple references, but a single reference cannot refer multiple. It's impossible. Okay? And basically why a constructor is used means, why we should go for a constructor means, if you want to write any mandatory logic while creating the object, if you want to execute any mandatory logic while creating the object, then we write the mandatory logic in the constructor. If you want to write any mandatory logic while creating the object, if you want to write any mandatory logic while creating the object, then we write the logic in the constructor. See, as you need not to note down the programs that we are writing. Okay, whatever the class content is, we are uploading that in the Facebook. Sharath will be uploading that in the Facebook. Okay, just you listen to the class, and if you want the programs, just this videos will be there in the Facebook. You can download the video and you can observe what we have done. See, don't concentrate upon writing the program. Just you can follow the video and you can practice yourself. Okay, you can clearly see what we have done and you can practice it yourself. Okay, so just try to understand what we are telling. Okay, and by seeing the video you can see what we have done and you can practice it your own. Okay, write a basic example, that's fine, but don't try to write the whole thing again and again. Okay, it's a waste of time. And yes, why we use the constructor means, if you want to write any mandatory logic while creating the object, then we go for a constructor. Okay, now in general the constructor contains the logic to construct the object. Okay, in general the constructor contains the logic to construct the object. The logic of constructing the object is nothing but assigning values to all the non-static attributes. Constructing the object is nothing but assigning values to non-static attributes. That is what constructing the object is. In general, in constructor, we construct the object. The constructor is used to construct the object. That means the constructor is used to assign values to non-static attributes of that object. In general, the constructor is used to assign values to non-static attributes of the object. So, we in general call that constructor is used to construct the object. That means in constructor in general we assign values to non-static attributes for the object. In constructor we assign values to non-static attributes of the object. So we have ID, age and name. This dot name equal to so while creating the object, okay, we should give ID, age and name. We can give the ID, age and name. Okay, let me give the ID. Okay, name. So like this, we can give the ID and age and name. Now, if this is the case, okay, if this is the case, and if I am changing like this, then what are the values printed? So if you see here, if you want to see the constructor, this is the constructor. Let me remove the unwanted spaces so that it is visible better. Just for the answer. What are the values printed? For the first two statements, p1.id and p1.name is 100 Srinath. Okay? And p2.id and p2.name is 10 Ravi. Okay? All of you have the same answer or compile them? Error. Why? There is no constructor with? There is no constructor with no arguments. Sorry, there's a mistake. The program was a little bit lengthy. So we have a constructor with no arguments. Okay. So need not comparison. Program. So 100 Srinath, 10 Ravi is output. And now even in the non-static methods also we can access this. Even in non-static methods also we can access this. See, in the test method what I am doing is, see, this is a reusable code, right? See, I am printing ID and name, okay? And this is a reusable code. I am writing it twice. See, just I am printing ID and name, which is a reusable code. I am printing the ID and name of the first object, and I am printing the ID and name of the second object. And this is the reusable code. And I am writing the reusable code inside some other method or somewhere else. Just what I do is I will write the reusable code here. Okay? And I can access this in a non-static method. This is possible. No? Just I execute. And even the method should have some specific name for the purpose of the method. Let me give name as print values. So it reflects the purpose of the method, why we are writing the method. See, if we see here, print is one word and values is one word. So in print P is starting with lowercase, just because method should start with lowercase. And if there are multiple words in a method name, the second word onwards it should be uppercase. Okay? So now just I am writing the reusable code. Previously I used to write 4 lines of code, and now I am writing 2 lines of code. I am reusing the same. Okay? Now the same thing. Okay, whatever the value present in P1, that will be printed first, and whatever the value printed in P2, whatever the value that is there in P2, it will be printed next. Let me change this again. Now what is the value printed? Okay, here in the print values method, this will refer to the object through which we have called that object, or through which we have called the method. Through which reference we have called the method? First through which method, through which reference we have called the print value method? Using P reference. Okay, now this in print values will refer to the object through which we have called this method. Through which reference we have called the method P. Wherever this P is referring to the same object, in this method this will be referring. Okay? This in this method will refer to the same object through which we have called the method. So here we have called the method through P2. So in for this execution, this will be referring to the same object where P2 is referring. So like that we can analyze and tell the answer.
Is it necessary to write this data? Necessary.
But just to demonstrate that it is possible. How it will work? First statement, what we have done? We have created an object. Okay? So the first object will be created with default values, ID as 0, name as none, and age as 0. Okay? And the temporary reference will be created to the stack. This is for the first step. Temporary reference will be created into the stack, and as the next step, what it will do means it will execute the constructor. Which constructor we are executing for the first line? The person constructor with arguments or person constructor with no arguments? Arguments. So the first constructor will be executed. In the first constructor, what I am doing? I am sending 127 Srinath. So the 100 will come here, 27 will come here, Srinath will come here. And I am assigning this dot ID equal to ID and this dot age equal to age and this dot name equal to age. So the values of the attributes will be reassigned. 100. So now this object creation is completed and the constructor execution is also completed. That means on the first line, the right hand side is completed. Now it comes to the left hand side. On the left hand side, what is person fit equal to something. So where on the right hand side we have the temporary reference. Okay. So wherever the temporary reference is referring, P2 will be referring to the same object. Okay. And if you come to the next statement, sixth statement, the temporary reference will be expired. Okay. Now P2 is referring to one object whose ID is 100, name is Siddharth, and age is 26. Now, what I am doing is person P1 equal to P2. I am getting another reference with the name P1, okay, and which is assigned with P2. Now, is P2 referring to any object? Is P2 referring to any object? Yes, P2 is referring to some object which is in the heap. Now, even P1 also will refer to the same object. Okay, again what we are doing? Person P equal to P2. Now is P2 referring to any object now? Yes. Even P also referring to the same object. Now, in the next statement, what I am doing? P2 equal to new person. Even though both P1 and P got the reference to this object through P2, when P2 changes object, Now in the next statement, what I am doing in the ninth statement, is 9 or 8? Ninth statement, what I am doing, I am trying to refer P2 with another object. So another set of ID, name, age. Now P2 cannot refer two objects at the same time. So it will break the bond or break the link with the existing object. Now, at the ninth statement, P2 is referring to one object and P1 and P are referring to another object. Now, if I change the value of P2 dot ID equal to 10, now this will be changed to 10. P2 dot name equal to some Ravi, this will be changed to. Okay. Now I am calling P dot print values. Okay. In the print values method, what I am doing? Just I am printing system dot println this dot ID. System dot println this dot name. Just I am printing ID and name. Okay. Now if I am printing ID and name, now first I am calling P dot print values. If I am calling P dot print values, and here this will refer to the same object where P is referring to. So now in this execution, this will be referring to this object. In the first execution, this will be referring to the object. Now what is the value present in ID? 100. So first it will print 100 and the name is 0. And the execution is complete. Again, what I am doing? I am executing P2 dot print values. If you are executing P2 dot print values, now this is not referring to this object. This will refer to this object. Just because for the second execution I am executing P2 dot print values. Now in the second execution, this will be referring to the object where P2 is referring. So what is the ID? 10. Name is 11. So this is how the execution goes. Understood? Now, right now I have created n number of objects, but I don't know how many objects that I have created. Okay? I don't know how many objects that I have created. So, what I do is, I'll go for integer count. Just the integer count represents the number of objects that I have created. The count represents the number of objects that I have created for person. Okay? Just I have declared a new attribute which is used to represent the number of objects that I have created for class person till now. I may create 10 or 20 or 100. This count is used to represent number of objects that I have created till now for this person class. Now, what I do is, let me consider that I'm using only the person object, person constructor which is nox. I'm not using this. Let me remove all these things. I created 3 objects. And in the constructor, what I am doing is, I am incrementing the count. All of you know what is plus plus, right? Post incrementation. Just it will increment by 1. Okay, it will increment the value by 1. Let me bring the constructor to front so that it is visible better. Okay, now just see what I'm doing is I'm creating almost 5 objects. Okay, while creating the object, what I'm doing is I'm incrementing the count. Now how many times this person constructor is executed? How many times this normal constructor is executed? How many times? 5 times or 4 times? 5 times. For this one time once, for this once, and for this once, for this once, and for this once. Totally 5 times the constructor is executed. Okay, now if 5 times the constructor is executed and each and every time I am incrementing the count. See, by default it was 0, and if I make count plus plus means from 0 it will become 1. We have to initialize count. See, count is an integer attribute. Attributes will get default values with 0. Do we need to do that? No. Just because count is an attribute and we will get the default value as 0. Okay? See, what I am asking is, okay, just for each and every constructor execution, I am incrementing the count. For each and every constructor execution, I am incrementing the count. Okay? How many times the constructor will be executed? How many times the constructor is executed? 5 times. Okay? Now, if 5 times the constructor is executed, now what is the value printed here? How come it will print 1 if 5 times the constructor is executed? See, 5 different objects are created and 5 times the same constructor is executed. If 5 times the same constructor is executed, 5 times this count plus plus will be executed. If 5 times count plus plus is executed, how come the value is 1? It should be 5 now? Understood the point? Understood the point? See, 5 times I am executing the constructor. If 5 times I am executing the constructor, 5 times count plus plus will be executed. If 5 times count plus plus is executed, why should not be the value 5? Why it should be 1? Okay, let me explain how it will be. This first what I am doing. See, in the fifth statement what I am doing, I am creating a person object. Okay? A new object will be created. Okay? With the values ID, name, age, 0, 0, 0, done. Okay? For the object which is created in the fifth statement, what I am doing? Okay, for the object is created and temporary reference is created in the stack. Okay, and next the constructor is executed. Which constructor I am using to which constructor is being executed? The first one or the second one? First one. The first constructor is executed. The first constructor what I am doing? Incrementing the count. So the count previously was 0. Now it will become 1. Okay? And if we come to the sixth statement, if we come to the next statement, now will the temporary reference exist? No. So this temporary reference is explained. And in the next statement, what I am doing? I am creating another object. I am creating another object. Now this another object will have ID 0, age as 0, name as null. Then what is the value of count? Will it be 0 or will it be 1? 0. Definitely 0. Just because each and every object will have its own set of non-static attributes. So, count will be 0 and we will be having a temporal reference which will be available to all in the statement. And then after creating a temporal reference, what it will do? For the second statement, it will execute the constructor. In the constructor, what we are doing? We are incrementing the count. Now, will the count will be incremented for the first object or the second object? Second object. Just because we are executing constructor because of the second object. Now, even for the first statement also. Now, if it comes to the first statement, the temporal reference in the second statement will be expired. And in the first statement also, what it will do is it will create a new object. Okay? And whose ID is 0. Name is null, age is 0, count will be 1. Even for the fourth statement also, ID will be 0, name is null, age is 0, count will be 1. Okay. Now for the fifth statement also, okay. Now in the system order principle also, I am creating a new object with ID as 0, age as 0. Name is equal to null and count is equal to 1. Now the next temporal reference will be referring to the fifth object. This is the fifth object that I have written. Now, what is the value in that? What is the value of count in that object? 1. So it will be the value 1. But if you want to really represent count to, if you want to really use the count to use, if you want to really use count to represent the number of person objects created. If you want to really use count to represent the number of person objects created. Now, is it correctly doing that? No. It's just telling 1 even if I created 5 objects. Just because this count is the number of each and every object. Okay? To solve this or to overcome this, okay, we have static. Okay, we use static to members which are common to all the objects of the class. Okay, we use static to represent members that are common to all the objects of the class. Now, is count common? Is this count common to all the objects of the class? Yes or no? Now this count is a non-static attribute, so it has this count is a copy into each and every object. But if I make the count as static, now will it be stored in the object? If I make count as static, now will it be stored in the object? Where it will be stored? Where count will be stored? In the class area. So the count will be stored in the class area. Let's consider right from the beginning. Okay? By default count value is 0. Even for static attributes, default value will be 0. So now count will be there in the object? Count will be there in the object or not? No, the count will not be there in the object now, just because count is a static attribute. Only non-static attributes will be there in the object. Okay? Static attributes will be there in the class area. So now let me try to create 5 objects here. Now the first object, first ID value will be 0, age is 0, name is null. Okay? And after getting the object, temporal reference will be created from the stack, will be referring to the current object, and the next step is the execution of constructor. In the constructor, what I am doing? I am implementing the count. Now, count is there in the object or in the class area? Class area. So, count will be incremented from 0 to. Again, a new object will be created. Now, the next statement, temporal reference will be expired. A new object will be created, and the temporary reference will be referring to the new object. The ID will be 0, age is 0, and name is null. And the next step is execution of constructor. Now, in the constructor, what I am doing? I am incrementing the count. Now, will this object have a local copy of count, or will this make use of the static count? Okay, it will be the same. The static variables or static attributes or static methods, static attributes or static methods will be common to all the objects. If you want to make any member common to all the objects, then we go for static. So this static is common to all objects. Now, will be the value of count now it is 0 or 1? For the second object, the count will be 0 or 1? 1. Just because it will be a shared copy. It will be a common copy for all the objects. So now the value is 1. Sorry. Now the value is 1. So 1 will be now incremented to 2. Now 1 will be incremented to 2. Now for the third object creation, now the temporary reference will be referring to the third object. Is 0, age is 0, name is null, and after creating temporary reference, what will do? Okay, it will execute the constructor. The constructor, what I am doing? I am including the count. Now count because equals to that will become 3. Okay, so for 5 objects, the count will become 5. Just because this count is shared by all the objects. This count is common to all the objects. Okay? If you want to maintain some properties or if you want to maintain some members common to all the objects, then we make that member as static. It might be attribute or vector. Okay? It might be attribute or vector. Now, constructor cannot be static. Constructor cannot be static. Why a constructor should not be static? Some of the interviews will be asking. Why a constructor should not be static? We may or may not assign the values in the constructor. It's not mandatory to assign the values. In general, we do that, but it's not mandatory to assign the values in a constructor. See, in general, we use constructor to assign the values, but it doesn't mean that it is mandatory to assign the values in the constructor. See, in general, in the constructor, we write the object-specific logic. See, for each and every object, there will be specific logic, and the object-specific logic will be written in the constructor. But if the constructor is static, means what happens? It will become generic. It will become generic to all the objects. It will become common to all the objects. But is that the purpose of the constructor? No. If you want to write the logic specific to the object, then we write the logic in the constructor. But if you make constructor static, means what happens? It will become generic to all the objects, or it will become common to all the objects, which will not serve the purpose of the constructor. So, for that reason, constructor should not be static. Just because the constructor contains the object-specific logic, and if you make it static, it will become generic to all the objects. Okay? Which doesn't serve the purpose of the constructor. Question? Understood everybody? Now, once we have ample knowledge what the constructor will do, okay? Now, all of you came to an idea, got an idea, what is the difference between static and non-static? Okay, now what is the difference between static and non-static? It is also a common question in interviews. What is the difference between static and non-static members? What's the difference? The first difference should be, okay, the static members are generic to all the objects of the class, but non-static members will be specific to the object. That's the first difference. Okay, static members are generic to all the objects of the class, but non-static members are specific to a object. And static members will be static members will be there in the class area, and non-static members will be there in the object. Non-static members will be there in the object, where the static members will be there in the class area. And static members can be used in non-static members directly. The third thing is, static members can be used in non-static members directly. But can we use non-static members in static members directly? No, it's not possible. Non-static members cannot be used in static members directly. And if we want to use non-static members in static members, what we need to do? We should create an object, and through the object reference only we can make use of non-static members. Now, can we make use of static members using the object reference? Can we make use of object reference to refer the static members? Can we make use of object reference to refer static members? Can we make use of object references to refer static members? See the example and then what we are doing. That's why I am asking again and again. Can we use object references to refer static members? Can we use? Yes or no? Yes. Definitely yes. Static members can be referred. Static members can be referred. Okay? Using either object reference or directly the class name. We can refer like this or even directly using the class name. Directly using the class name also we can refer the static members. The static members can be referred either by the class name or even the object reference. But can we use the non-static members like this? Let's consider like I'm using can I use non-static members using the class name? No. Non-static members cannot be referred using the class name, Non-static members should be referred through the object reference only. Non-static members should be referred through the object reference only. But static members, they can be either referred through class name or even through the object reference. Static members can be referred either using the class name or even using the object reference. But non-static members should be referred only using the object reference. We cannot use the class name as a reference for non-static members. We cannot use the class name as a reference for non-static members. Now, what the compiler will do means, the compiler will check here, okay, to which class we are creating the object. To which class we are creating the object? To which class we are creating the object? Person class. Now it will check, in the person class do we have any attribute count? In the person class do we have any attribute count? Yes, we have attribute count. Okay, and at the runtime what happens is, see, at the runtime, what happens is, okay, now in the compilation time, just I'm giving SOP in place of system. So in the compilation, at the compilation time, what happens is, okay, first it will check, okay. If I am referring a object reference dot some number, okay, first it will check, do we have any non-static member with the name? Do we have any non-static member with the name? The name count, do we have any non-static member? No. So now next step is what we will do is, within the class, what is the class for which class we are taking object? Person. Within the person class, we will check for a static member count. Do we have any static member count in the person class? First it will check for non-static member. There is no non-static member present in the object, then for that class we will check for a static member with the name count. Do we have any static member with the name count in the class, person class? So now the count will be referred as a static member. So the compilation will succeed. But at the runtime what happens is, at the runtime, when the runtime environment finds this as a static member, then the runtime environment converts this code to like this. The runtime environment will convert this code to this. Just because the runtime environment found that count is not a non-static element, count is a static element. For static element or static method, at the runtime environment will convert this code like this. So at the runtime environment, okay, we have person dot count. Now can you tell that at the runtime environment, okay, a static attribute or a static method will be referred only by the class name? Now can you tell that at the runtime environment or at the runtime, during the runtime, a static attribute or a static method will be referred only by the class name? Yes. Can you tell like that? Yes. Just because at the runtime, even we give the object reference as the compilation time. Even we give object reference as in the code. At the runtime, what the runtime environment will do is, it will convert this code to the class name as a reference. So, at any cost, at the runtime, non-static members will be referred using the object reference and static members will be referred using the class name. At the runtime, non-static members will be referred using the object reference and static members will be referred using the class name. Just because even the static members are referred using the object reference, the runtime environment will change the code to refer using the class name. Understood? The runtime environment will change the code so that, okay, the static members are referred through the class name. At the runtime, definitely all the non-static members will be referred through the object reference and all the static members will be referenced through the class name. Even though in the code, if you are referring the static members through the object reference, at the runtime, the runtime environment will change the code so that it will refer the static members, the static attributes or static methods are referred through the class name. Understood? That's how it will be. So we can refer, we can refer the static attributes or static methods using either the class name or even the object reference. It will be compiled and executed successfully. But we cannot use, we cannot use the class name as a reference for non-static members. Now will it give a compile time error? Will it give a compile time error? Yes or no? Yes. Definitely it will give a compile time error. Just because we are referring person dot id. Person is a class name and dot id. id is a static or non-static? Non-static. So id which is non-static cannot be referred using the class name as a reference. But count which is static can be used using object as a reference. But the runtime will be converted into person dot. At the runtime this will be even this will be converted to this. At the runtime even this will be converted like this. Okay? Like that it will be, and if we try to compile this, it will give a compile time error. Just because non-static variable id cannot be referred from a static member using the class name as a reference. So the ideal way is using the static attributes using the class name only. It's not a standard thing to use the static attributes through the object reference. It's not at all a standard way. It's not at all a standard way to use the object references to refer the static members. Static members should be referred only through the class name. It's a standard way. It differentiates between calls to static methods or calls to static attributes and calls to non-static attributes or methods. See in the code we can clearly differentiate. Now count is a static member, so it is referred to the class name. id is a non-static member, so it is referred to the it is referred through the object reference. So seeing the code itself we can see that count is a static and id is non-static. So that kind of differentiation we should do. That kind of standards we need to follow that. We should use only the class name. It's not a rule, it's a convention, it's a standard. There is a rule, there is a difference between rule and convention. Rule means it should be followed. Convention means it's better to follow the convention. It's better to follow that. So it's not a rule that we should use class name as a reference for static members. It's just a convention and we should follow the standard. So wherever you refer, you should refer the non-static members using the object reference and static members using the class name. Now let's consider that. Now will it be compiled and executed? Will it be compiled and executed? Yes. What are the values printed? 0 and 0 and 5. So the values printed are 0 and 5. No. Now, will it give a composite error? Will it give a composite error? No. Okay, what's the value printed? 0, 5 and 20. Okay, now we are referring the static attribute I of member demo through the class name. But if it is within the same class, it's not required. If it is within the same class, it's not required to have a reference. But if it crosses the boundaries of the class, then only we need to have references for class static attributes. See. If we are making use of static attribute or static method of one class in another class, then only we need to have a reference. Otherwise, it's not a problem of having a reference, but it is not required. Okay? Is this really required to have member demo.I? No. Directly we can place just because it is within the same class. Okay? But now can I use count like this? Can I use count directly like this? No, just because count is a static attribute of person class. The attribute of person class is being used in member demo class. So, if you want to make use of static attributes of one class in another class, then only we should have a class as a reference. But if you are using the attributes, the static attributes within the same class, if you are using the static attributes within the same class, then we need not to have any references. Directly we can use using the attribute name. But if we are trying to use the static members of one class in another class, if we are trying to make use of static members of one class in another class, then definitely we should have class name as a reference. It will be applicable even for methods. I have discussed for attributes, it will be applicable even for methods. Non-static methods should be referred through the object reference, and static methods can be referred either using the object reference or the class name. But the standard way is referring the non-static attributes or non-static methods through the object reference, and static methods or static methods or static attributes through the class name as a reference. That's the standard way. Standard way is static methods or static attributes should be referred through the class name. Non-static attributes or non-static methods should be referred through object references. That's the standard way. Okay? Now, can I use I here? I is the attribute of member demo class, and I am using I inside the test method print values of person class. Can I use I directly here? No. How I can use I here? By using class name as a reference. Member demo dot I. If it crosses the boundaries of the class, then it should have a reference. Okay? Like that it will be.
So, can we use this also in the same class?
Within the
same class, this dot I.
where within the same class means where? 30? 38? 13, 13. See, as we told, this is a non-static reference. Can we use non-static references in static method main? No, it's not possible. That's what we told, right? In the exercise class itself we told this cannot be used in main method. Just because this is a non-static reference. And non-static references cannot be used in static methods. Okay? This can be used in non-static methods as well as constructors. But this cannot be used in static methods. Okay? Still we are supposed to switch to the third member. Okay, now with this the constructors will be done. Constructors concept is completed. Okay. Now as the next concept we are supposed to discuss initialization blocks, but it's not the correct time to start initialization blocks as we have less time. Okay. In the next class we will start about initialization blocks. Why initialization blocks are used, and where we can declare them, and how we can declare them, and how they are executed. And one more thing, okay, we will be having a vacation from 15th to 19th. Just I'll be going to my hometown. Okay. So if you want to plan to go to your hometown, you can do that from 15th to 19th. Okay. From 15th to 19th there will not be any classes, as I'm going to my hometown. If you want to plan your vacations, you can plan. And for that reason, in order to compensate that, we will be having a little bit long class on Saturday as well as Sunday. Okay. If possible, we take Sunday also. If not possible, we have a long class on Saturday.